1934 as I can fit in today. I hope you've enjoyed these swinging memories as well.
Well, in this segment we're going to take a look at the software that runs this radio. Now it's a Python program. It uses a variety of dependencies, and as typical I'll walk you through the process to install those dependencies. The Python program is provided to you. We'll be providing links to all the different components that are needed for this radio project. I'll be showing you how to add additional internet radio stations, how you can set it up as an MP3 player, and how you would organize your files in that format, and anything else that I feel that's important for you to get the radio up and running as it's designed right now. And of course, you'll have the source code so you can modify this to your heart's content and make it your very own. Let's dive right in. Like all Raspberry Pi projects, we got to create an SD card with the OS on it. I myself like to use the Windows Imager software, and very simple to use. Let it do its thing, and then we'll move on over to the Raspberry Pi. Okay, I've put the SD card in the Raspberry Pi, booted it up, keyed in the localization information, country, keyboard, that sort of thing, and then set up the Wi-Fi with my network here, and installed some screen capture software so that I can show you what I'm doing on a Raspberry Pi screen. If you haven't already done so, now's a great time. You would download your files from the link we'll be providing. They should be in your downloads directory after downloading. And we're going to copy this and paste it right here on the desktop. And I'll quickly point out what's in that folder or these folders so you understand what you're looking at. This config.txt, you're not going to use that folder directly. It's just for reference only. We'll get into that in a little bit. This is the iradiostations.txt. This is a listing of the radio stations that I'll provide with the software. You'll add more to this list as you see fit. You'll want, of course, adjust it to your musical tastes and so forth. This is the actual Python program. Inside this graphics folder are two images. Hopefully I'll be able to find the originals and provide links to those as well. And these are just a couple of logos that I got off of a Google search that I thought gave the radio a good classical look for the time period. Of course, you can substitute that with any images that you want. Now what we'll do, we'll go ahead and open up Thony. Okay, we'll open up the radio Python program that's in the radio folder. And we're going to take a look at getting some of the dependencies installed. If you want to learn more about the encoder library, you can go to this link. Otherwise, we can just simply type sudo, I always do sudo, pip3 install encoder. And that should be installed. Now, sometimes I run into situations where it's either pip or pip3. In these situations, so if one doesn't work, try the other. And I'm going to add the sudo here for your notes further on down the road. And then we're going to install this library. And if you don't want to type it, copy, paste, and let that install. That went very quick, so I assume the library is probably already on here. Maybe not. Next up, we're going to need to edit this config file. And this is to make that 5-inch display from Adafruit actually work. If you don't do this step, that display will not work. Now, I'm going to go ahead and show you how I edited it but I don't want it active yet because right now I'm running on a full-size monitor here. If I activate it, then this monitor gets all goofy, but you'll understand what I mean in a moment here. First thing we'll do, let's go to our radio folder, and here's that config.txt. So we'll open that with a text editor, and I'm going to close this out and squish this guy down. And then over here, we will do, I'll just add to this sudo nano boot that. We'll copy this, paste that here, and this is the standard installation config.txt file. Now, what they're recommending, we want to make sure that this HDMI force hot plug equals 1. Make sure that that's uncommented. Here it is. A little cursor down to, oh, I was right on it. How you like that? Cursor down to that. Next up, I added these lines. I'm going to copy and paste that. Oops. Copy. And paste that. Now, when we go to run on the little display, we will uncomment these 5 lines here. Of course, not the description above it. But we'll uncomment those when we plug in the little display. So for right now, we've made those changes and we can save them. And of course, I would highly recommend, and I'll provide a link here for it, for you to review this information on the Adafruit website. They go through all the configuration data for this particular display, and you never know. They may update something that I didn't catch here, and that could be very beneficial to you to get your system up and running. So over here, we'll Control X, yes, save, boom, we're done with that. With the first few dependencies already loaded, I'm going to go ahead and try to run the program. Most probably I'm going to get an alarm. Here it is. And if I get that error, and this is another one where it seems like sometimes I get it, sometimes I don't. So we're going to copy that and run that code in our command prompt. Oh, double click, paste. And that'll load up that package. What I'm trying to do is work my way up to the point where we can get it running, and then we're going to move on and try to load up some fonts here in a second. Okay, hopefully that did everything we need. We'll close the command prompt, try to run it again. Okay, it's having some errors here. I kind of got a hunch those we can probably ignore, but we've got the program is running. You should be seeing what I'm seeing here, which would be a couple of the old RCA logos, volume control bar, list of your radio stations should be here, time, date. Don't worry about those 2 marks there. Those are hidden by the display or the radio housing. But the font isn't right in here. And so what Linux is doing is it's just grabbing another font and substituting the missing font. So now we'll go hunt down the font that we want and get that installed. So we can click here and click off to close that out. Okay, now we're going to move into this area. This is a website I found, how to install fonts on a Raspberry Pi. I believe that's the one I used when I wrote the software a while ago. So we're going to go there, and the font, that'll lead us to this website, which is where we want to get this font, Cleveland Demo. So from this website, let me shrink this down so we can see both at the same time. We're going to scroll down, and we're kind of jumping ahead here. But the website that we want is 1001 Fonts. We'll go there. And we'll just copy and paste this in. And we'll search for that. Here we go. Cleveland Demo Regular. And we will download that font. And now it's in our downloads directory. And from there, we'll go back to this other website, How to Install Fonts, and we'll follow the instructions they provide. Double click on the file name. That's the font right there. We'll go ahead and extract them right here in this folder. Now that we've got it extracted into the downloads folder, we need to get that to the appropriate folder. It's telling us to go to the home.py in File Explorer. So that's this folder. Create a new folder and name it Fonts. We'll use Control H to display that. There it is. Now we'll go back to our other folder, our Downloads folder. We will copy that and paste that here. And now, according to this, we should be ready to use it. So to test that, we're going to go ahead and run our program, and look at that. Right now we're using the Cleveland Demo font, and it's a nice looking font for this vintage radio. Okay, now we're going to go through and redirect our audio output from the HDMI port to the analog port, which is your speakers. And on the newest OSs, it's been pretty easily done by simply right-clicking on the speaker icon, your volume control, right-click, select analog. And that should set you up for analog output. Now, I have had recent Raspberry Pis where that didn't work, and I had to follow the steps that I've listed right below here with a link to the source of the information. But hopefully the speaker icon will do the trick for you. Okay, I'm going to turn the volume up, and we're going to run the program now that we've got what I'm hoping are all the dependencies loaded. Boom! We've got music on our speaker system. And we've got volume control. Our encoder switches are working. At least the volume is. And let's see if I can select an appropriate radio station. All right, we're going to go through a bit more testing here, and then we'll start getting ready for final assembly. Try the MP3 player, and plays the first song in the list. We'll scroll through it. I'm going to go to times 20 so I can fast zoom through this. And this is listing all the different songs that I've got on my library. Obviously, I can't provide my MP3 files to you, but I'll show you the directory structure so that you can set up and create your own MP3 file list. One thing you may have noticed is that I'm now running the program through idle. That is, I loaded up the Python 3 idle IDE, integrated development environment, and am running the program via that. And I have a lot less problems with it. I don't know what it is with Thani, but I get a lot more unimportant errors, I guess we'll call it. So just be forewarned of that. Okay, now we're going to take a look through the whole Python program, radio.py, and I'm going to show you how it works and point out the configuration areas and all that fun stuff. Now, I've already walked you through the settings, the analog output, the dependencies, and how to get all those installed. We'll address the radio stations toward the end of this. Here's something that you will most probably want to do, and that's set up auto run for your program, your radio.py program. That way when you plug in the radio and turn it on, it automatically loads up the radio program and starts playing some music off of one of the internet radio stations, the first one that's in the list. Very simply, you're going to open the auto start script, which is done with sudo nano in this line here. You're going to add this line here to the end of that program or that file, save and exit, and then reboot. As I note here, you would want to, I recommend making this change after you're completely satisfied with how everything works, as it can be somewhat of a pain to work around sometimes. Same thing with how something else will happen later in the program. So saving this to the end is probably the smartest thing to do. The MP3 directory structure, we'll come back to that later. Operation of the radio, quite simply, there's two knobs on the radio. Left knob is volume, clockwise increase, counterclockwise decrease. And then if you push it, that'll toggle the display to either bright or dim. It does not actually turn it off, it just dims the display. The right knob, like most radios, would be your tuner dial. Clockwise would scroll down the list, counterclockwise would scroll up the list of either stations or songs if you're in MP3 mode or in radio mode. There's no function yet assigned to the push function of that knob, so if you got an idea, you got an open button there. On the touch screen, there's two areas where you'll activate or use controls that would be functional through the touch screen. If you touch the top logo, that will bring up a menu, and from there you can select whether you want it to be an MP3 player, a radio, internet radio of course, or you're going to turn it off, which depending on a setting further down in the software will either completely shut down the Raspberry Pi OS or it will just stop the program. You'll have that option to change that line of code later. Then near the bottom of the screen, what'll happen, a menu will pop up there, and that will present to you X1, X10, and X20. And that'll pop up when you rotate the right dial. And if it's on X1, for each click of that right knob, it'll move either up or down one selection. If it's on X10, or if you touch X10, it'll move up or down 10 selections, and X20 will move up or down 20 selections. And that's how you can move through your list very rapidly. We're going to import a number of libraries. Most of these are already in your system. Any of the dependencies, we've already discussed that. This sleep statement I added here, I'm not exactly sure why it was needed, but I had to add that in order for the auto start function to work. And that had to do with what I described up in this area. So just adding a sleep for a few seconds seemed to do the trick. I wish I could explain it, but unfortunately I couldn't get to the bottom of it. We're going to set up our GPIO function or library, and we're going to set it up into BCM mode for what pin is what. It's going to use BCM coding. We're going to set up our encoders. This is just referencing pins 10 and 9 and 2 and 3 for channel A and B. And we'll have a tuner encoder and a volume encoder. System variables, here's just a number of pretty simple ones that just help us keep track of what's going on. The shutdown state is how I know whether to keep it in a loop running or to abandon it, abort the loop and then do a shutdown, whether the radio's in radio mode or MP3. A lot of these are really just pretty straightforward. They just are counters or pointers to what our current selection is on the selection list. Defaulting to mid-level volume, radio state is what we would be in, and then the dim bright flag is off. We're going to establish our user interface main object, and I call that WinRoot. That's to Kinter. I'm going to set it up for our display at 800 by 480 pixels. That's the size of your 5-inch display, and it'll be at coordinates 0, 0. And then this line here, when it's active like this, there will not be any of these controls. This bar here will not show up on your display, and your close button and minimize and maximize buttons are not shown, nor is this menu. That way, your user interface, like on the radio, occupies the entire screen and you don't see the typical Windows type things. So you will set that like it is when you're running off of the actual radio and you've got everything up and running. We're going to set up a socket for communications, and that will be for doing the IP radio portion, where it's going to set up a socket and a connection to a host where we're trying to get the radio data from, or the music. Here's just a very simple function that's going to translate a tuple of integers into a Kinter-friendly color code. And you'll use this further down in this area here, where we're going to set red, green, blue. And you'll see that I want, for this example, R10, or radio 10 color. I want this to be equal to this as returned from the function there. And then these are just RGB values. And you can actually get those if you're on a Windows computer and you select a color, and then if you edit that color in that paint program, it'll tell you the RGB values, so that you can use those right here. I did note that the 5-inch display did not color match this particular screen very well at all, so I actually had to create a color background function strictly for that 5-inch display right here, with a couple of different examples. You may want to tweak those colors to suit your needs and suit your monitors. And then I just set a few more variables for our graphical user interface. Now we're going to set up, in this whole section here, we're going to set up a number of screens that are containers for all of our graphical elements. Now I've started up the program so that I can reference this information to what's on your user interface. Now our main screen would be this whole area, and as you're seeing it here, it's kind of orangish in color, but on the actual radio it's kind of tan. Then we've got our bottom title, which is this, just a little element to make it interesting. Then we've got the current time and today's date, and those items are here and here. These are just the objects to display that. It's not actually displaying the value yet, it's just an object to display it. I wanted to include the IP address on the screen, so I put it here underneath this volume control or volume level indicator. And then that way, if you're VNCing into it like I do all the time, should your DHCP give you a different IP address, it should show it for you, so it's easy for you to get into the radio with your VNC software. There's text for the speaker volume and tuner counters, and those are down here, and they're really not visible at all on the actual radio because we've got that rounded corners, so this area is actually masked off. It's just kind of there as a helper when you're testing things here on the big screen. We're going to create a container for a graphic image on the left screen for a logo, and that's this little guy right here. This is a very classic RCA logo. I got it off the internet, and I will be providing a link for where to get it, and I'll include it here in our package as well. But all this just displays it and sets it up in this area and tries to clean it up a little bit so the edges are nice and sharp and so forth. Of course, you can put whatever you want there as well. We're also going to create a container for a graphic image on the top of the screen for a logo, and that's this logo here. Again, another very classic one. And again, we're setting it up with the size, the place of it, anti-lace for cleaning up the edges and so they don't look so jaggy and so forth. And then we're going to create a container for a pop-up menu to select MP3 Player, Radio, and Power Down. And that's these three items here. And this is how they're, the logic behind these. So let me call it up. Okay, so these lines here create this box with these three buttons. And then if you click any of these buttons, it'll run either of these three subroutines. And that's all tied together by, here's our MP3 button, MP3 button. If you click this command will run activate MP3, which runs this function, which will set everything up so that it becomes an MP3 player. So that's all this. There's not any real magic or anything complex in there, just basic, very simple steps and function calls. So we'll select that to make that go away. Yeah, I got an error here, but that should be all right for what we're doing right now. The volume control, which is over here, and of course the associated encoder. This is the display and the logic for the volume control. So here we're setting up the graph. We're drawing the graph and making these little lines around it, and see if I can make it operate here. Okay, as I turn the volume all the way up to 10, you see it get big. All the way down, I'm rotating the rotary encoder, by the way. And that's what all this is doing here. This is just setting the shape and size of that little arrow, and then setting the volume levels. Now this is the right encoder multiplier controls, and I'll again rotate an encoder so that you see those. You'll have X1, X10, and X20, and you would just click on these with your finger on the touch screen. This would be for the encoder to go one line at a time, or two or three, one line at a time, 10 lines at a time, or 20 lines at a time, so you can get through your list of songs very quickly, your radio stations. But this creates those little controls here. This section creates those, and then this function performs the action based on what you select there. Now we're going to take a look at this section of code. That'll actually start here with create display mechanism for selection list, and that will end roughly about here. So we're going to cover a few of the functions and the setup of the display. Now at first it may seem far more complicated than it really is. So first I'm going to explain to you what's happening here then we'll look at the code here. Now in this area, there is one function that will display either the internet radio stations or the MP3 files that are on your flash drive. So it has to handle either or. Now, for example, we're looking at the internet radio station listing, and we're just saying Classic Rock Global. Well, that's the name of the radio station or the internet radio station. Also in the file for this is the URL to that station. So this function has to take into account two different types of data as well. Now, in this area of the screen, we've got room for a total of 13 radio stations or songs to be displayed. And this function only displays 13 pieces of data, not all the radio stations and not all of the MP3 songs. So as you rotate this encoder, your rotary encoder to tune, of course it's got to index and move down or move up. But what's really happening, this list of displayed data is being recreated each time you move up or down in the list. It always only contains 13 items, and we keep track of which is the current selection so that we can correlate that back to the master list, which is the entire list of radio stations or songs. So the function has to be able to decide what to do when it gets to the end of the list. In this case, it just stops, or if we scroll up, it just stops here. It doesn't go up and above. So here in reality, these 6 items are blank, and item 7 is this radio station, and then these next 6 stations are listed. So that's what is happening in here. So it requires us to create several different lists to manipulate and display that data. That's really all that's going on. So probably the most important thing for you to be aware of is this one right here. Number of selections to display, 13 of them. Now, depending on how good your eyes are on the actual radio, this might be too small for you to see, so you might need to increase the font size. Well, that would make the list longer, in which case you would decrease the number of things to display. So that's probably the most important element of this whole thing here. The rest you can pretty much just treat as a magic box, but we'll go through it real quickly here. We're going to have the selection display list, and that will be this. This is what we see here is the selection display list. And we will have to load that list every time you rotate that rotary encoder up or down. This is going to explain where we want to display the data, spacing between the lines, etc. We're going to create a selection marker, which is that little pointer there, a little triangle pointing to the right, and these are the dimensions of it. And then from here, we're just simply going to append these items into that list, with this item being done in bold font and all the rest of them just in a normal font. We're going to have a list that will have the path and the descriptions, and we're either going to load that with radio stations, or we will load it with MP3 files, or tunes as I call them. That's what these two functions do. And of course, these are the paths to that data. Here's the path to our internet radio stations text file, and that's on your desktop in the folder radio. And then this one is looking to your flash drive main media. In this area here, this function is going to populate these 13 items in this list from the display data, or from the data from these either radio stations or MP3 files, the tunes. And that's what that function is going to do. It's going to populate it for initial display. And then when you rotate the rotary encoder switch, it needs to be updated. And that's this function here. This will go through, reload the data into this list so that it displays the information within our range that we're looking at right now. So seems like it's really complicated, but if you walk through it step by step, it's pretty straightforward. So that's what these functions do. It deals with this part of the radio, which is really somewhat the user interface heart, if you will. And then finally we wrap it up on these three lines, which are run at the start of the program. Notice they're not indented, so they're not part of this function. But we're going to load the radio stations into our display list. We will populate that display list. And then finally we will update the selection so that it shows up as this when you first power up the radio. So again, these three just run at startup, and they call these functions to perform those tasks. Okay, now we're going to talk about the player function. The player function is an object that is the VLC media player. We loaded that in the dependencies, and we establish it here outside of the function, and then I declare it inside the function as a global variable. And of course, it's a little bit more than a variable. It's actually, we'll call it an object. And what we can do with that, within this function, I can then, because it's a global variable and a global object, I can tell it to stop playing. I can adjust the player volume. I can make the player play, etc. Now, the thing to understand, which will probably make more sense right here, notice how it says player equals VLC dot media player. And then we're going to pass it this MTP media to play file where I'm going to strip out any new line characters should they exist. Sometimes they show up in the URLs hidden. So you can see it's just not an ordinary variable. It's actually the object of our media player, our VLC media player. But as we come into this function, in the case of we just selected a station to play or a media to play, it'll stop it from playing, which may cause an error, so we just ignore it. We assign the media value, the URL or the path. We measure its length. I don't know if we still need that or not. I think I could lose that because that was part of the debugging to do the stripping of this new line. But here's where we recreate the player with the VLC media player. And then we're going to adjust the player volume because it's always, when we start it like this, it defaults to a value, a volume level, but we want it to play at the volume that we set. So I establish it. I then immediately set the player volume, and then we start the media to play. So it does a lot in here, but it's truly very simple when you kind of mess with it a little bit. Our volume control is even simpler yet. Again, we're working with that player object, so I'm treating it as a global variable, so we address the object there. We either increased it or decreased the volume to get into this function. And the actual player uses a range of 0 to 100. So we just take our range, which is 0 to 10, and multiply it by 10. So we set the player volume to a value that's in the range of the actual module player. Then we just simply set it. Player.audio set volume, that value, which would be 0 to 100, which was modified from our internal values of 0 to 10. Again, we try to capture any errors, which is usually you try to do this and nothing's playing. We really don't care about that, so we just ignore that altogether. Moving into this area, we're going to create I'm going to call it a filter, which is more how from photography and so forth. We use filters to alter whatever we're taking a picture of. We're trying to adjust color, contrast, brightness, intensity of colors, etc. In my case, this is what I'm going to do, and I'm going to press the volume control push button. Notice how this gets really dark. I press it again, and it gets bright again. And that's how we're simulating turning it on and off. So what I'm doing is creating a rectangle here and setting it up with an alpha channel, meaning it'll be somewhat transparent. That way when we hit the button, we can still see the original text and graphics. All I really wanted it to do was look like the lights were off on the radio dial, as they would have done in the old days. So that's what this is actually doing. It's creating a rectangle in this area with an alpha channel. Then I'm going to filter, my filter on here is black, but because we're creating this screen over the top of everything, and it's got these alpha channels, it'll come up as just simply, we're placing these rectangles here, here, and here that are of this type, meaning they have an alpha channel. We're placing those over the logos, this logo, and in the entire background. That'll make them look dim because it's an alpha channel, it's semi-transparent window. Then when we want to make the screen bright again, as if we turn the radio on, we just clear out these three rectangles and all is well. Then it gets nice and bright again. So all we're really doing to make the radio look like we're turning it off, we put three filters or three screens that are semi-transparent over this area to hide it partially. It's a lot of code, and it's kind of convoluted to just get that function to work so that we replicate or simulate turning the radio on and off. I didn't want a full on or off because for a Raspberry Pi to power up, it can take a minute, maybe longer, and that's a long time to wait for the radio to turn back on. The radio's only pulling about, I want to say, at 12 volts, I think I measured it was pulling about less than a half an amp, so it's not using a lot of power. So I just thought I'm okay with wasting a little bit of energy to get the look I want, but more importantly, the convenience for immediate on and immediate off. Here we're going to handle the push button functions of the rotary encoder switches. On the tuner control, your right encoder button, it's set up on pin 11, and that's done at this line. This sets up the interrupt for it on pin 11 when it's going low, and it's going to run this function, which at this time just simply says tuner push button released. And if I do that, hopefully you can see that here. You can see all it's doing is that. So that's actually a button that you've got available to you if you want to customize the software. You could make that maybe toggle between MP3 Player and radio function, or maybe make an alarm clock, whatever you want to do. Have fun with it. The volume control push button is the one that actually sets a flag to make the screen dim or bright. It actually doesn't run it here because there's other things that go on within the Tkinter software. We're running this function to do actual Tkinter modifications. It gets a little problematic, so I actually handle that through a timer in our main control loop. But up to this point, these are all the functions to make the radio play. Not a lot to it. I probably went into far more detail than what was needed, but I just wanted you to be a little bit familiar with the program, how it's working, and hopefully encourage you to modify it and make it your own. Now the main control loop I do have to point something out to you. If you're familiar at all with decanter programs, this is maybe a little bit on the unconventional side. But for me, it gives me the freedom to do what I want the way I want. Now, this is our main control loop. Down here further is Decanter's main loop. Now, you'll see here I got WinRoot update. This actually runs in this, but when you're in a loop like this doesn't run. So that's why we put it here. But I can't do this stuff inside this loop. So this is just a workaround for it. We're not violating any rules. It ain't going to break anything, nothing like that. It just gives us a way to control our program. So in the main control loop, we've got some configuring to do here. We've got some timers that we're going to set up and set some default values for the current state. And then the loop runs as long as shutdown state is equal to run, and the only time that's not equal to run is if you click that button. You click that button, that sets this variable to something other than run, and then the loop exits. And we'll go right to there right now. That'll exit down to here, and the player's going to be told to stop. It's going to sleep for a second, and then we're going to destroy the Decanter application, which will kill most of it, but not all of it. But it'll be enough to get you out of the program so that you can get back to the Raspberry Pi OS. This line right here is something that will shut down, like if I click this, it'll shut down the Raspberry Pi, but it will not turn off the power. So keep that in mind. There is no power switch on this radio. It's violated one of my own rules in the design, but the way I intended it to be used was to never be turned off. So during your initial testing and all that, I would recommend you comment that line out until you got everything working good, and then and you're running 100% off on your radio, then you could uncomment that, so that when you then click off, this will shut down not only the Raspberry Pi radio program, but it will shut down the operating system as well. Okay, now back to the top of the main loop here. I've got a 1 second counter going on here that if I go through this loop 20 times, it'll give me essentially a second of time. And that's primarily because down here we're sleeping 0.05 seconds, 50 milliseconds. But in here we're just going to update the IP address and the date and the time. Sorry, I had to do that. And then we will calculate the date and time, format it, and then display it up here. So that's all this function is doing, is just providing you with information. Date, time, and the IP address. This section here is going to help us determine when the current song finishes playing. We're only going to do that when the current mode is in MP3 Player or the radio is on. We don't want this running any other time. So we'll get the position, and we will get the duration from the player object. And if the song is playing, yes. And if the player is playing is not equal to 1, then skip to the next, equals yes. Otherwise, song is playing is set to no. I'm sorry, not otherwise. It's just simply skip to the next song, yes, and the current song is not playing anymore. It's kind of a convoluted way to find the end of a song, but that's the way it seems to work. Here we're going to read the right rotary encoder switch. That's called tuner. We're going to read the count in it, and that counts by 4s So this new tuner counter is going to take that value and divide it by 4, so that for every click we get one increment either up or down. In here we're going to make a few decisions as to whether the encoder was adjusted, and if it was it incremented up or was it incremented down? And then also if the IMS position status is hidden, we want to show it, and that's this data right here. So whenever you rotate it, this is saying show this, and then it'll leave it up there for X number of seconds, and then it'll automatically disappear. Here we're looking at the automatic function of playing MP3 songs. So if we're skipping to the next is true, and the current mode is an MP3 song, meaning the previous song has ended and we're in MP3 mode. Skip to next is no, but increment by 1, and then adjustment by automatic. And that's where we had to kind of differentiate up here between human intervention and automatic intervention. In this section here, we're just going to adjust this display information here, and at this point we're still dealing with the rotary encoder was rotated X number of steps. Now we have to factor in the times 1, times 10, and times 20. So what we're going to do, if has been a change, we're going to deal with it. If the current selection is less than all the songs, then we'll subtract 1 minus the increment multiplier, 1 times that, and we'll either go up or down. And that's these lines right in here. And then, of course, if we're automatically indexing, because it's being run in MP3 mode where it automatically goes to the next song, then we'll roll back to the first song when we get to the very far end of it, of the list. So in other words, when you rotate the dial, you get to the very last song on your MP3 file list. Instead of stopping, it'll actually roll around to song number 1 and present that back to your list. So that's what's all going on for this area in this section. Now, here we're going to look at if a selection has changed and if at least 1 second has passed before starting it. So in other words, as we roll this down, I'm rotating the encoder switch, and then it's going to stop there. If at least 1 second has passed, I'm going to assume that we're ready to play this tune. Otherwise, as you're scrolling, you don't want it to switch to the other song every 5 milliseconds or something. It'd be very difficult to deal with that on all these libraries, especially opening and closing these media files. So I just make it wait for a period of 1 second that you sit on a station or a song, then it'll play. And that's what's going on in this function here. Here you can see we're going to run the function play selection, and we've already covered all that above. And then we set the flag that yes, the song is playing, and so forth. So that's how we're dealing with automatic play of a song from the list, either a song or a radio station. Then this timer routine here is going to wait 10 seconds, so that'll be on display for 10 seconds. Then it'll go through and then hide these controls so that they disappear after 10 seconds. Now we're going to process the volume control input. So we read the volume encoder, rotary encoder, that's your left rotary encoder. Again, we divide it by 4 because that's counting by 4. It's a quadrature encoder. And then we're going to convert the absolute counter to an incremental counter. And all of this is just doing this much for you. This counter is going to be in a range from 0 to infinity plus, 0 to infinity minus. And what we need to do is have our volume level from a value of 0 to 10. So all of this code breaks down that huge number, or potentially huge number, so that it's just simply a number between 0 and 10. And that's it. So all of this just to do that. And then here it will update the volume graph, which is this guy. And then here it'll run the function to set the player volume to what we've got selected here. Now here is the area where we're making this dim and bright by hitting the push button on the volume control. I've got my timing all wrong. We're going to, when you press that button, this is going to dim this from here. It's again, this is a Tkinter function that we're controlling, and I can't do that in a callback function from an interrupt. And if you remember, let me get back to that code here. These were interrupts, so you can't call Tkinter functions from in that function, at least not simply. So that's why we're doing it in here. We set the flag up there, and then every 50 milliseconds this passes by, and if we got to do something with that, we're going to deal with it right away, which is to display the dark screen. Here, dim the screen, set some flags. We're going to pause the player so the music isn't playing. Otherwise, we're turning it back on and setting it into the bright screen mode and turning the player back into play. And then here we are at the end when root update updates all our graphics and Tkinter functions, and then we just slow down that loop to 50 milliseconds, which is 20 times a second. And then we've already covered these sections here. Now this really does, probably my explanation makes it more confusing than how it really is. It's pretty straightforward code. To me, the only really complicated parts were the socket, because I'm not very familiar with it, but I just used what was recommended. And then getting into, we'll call it the counter here, dealing with the absolute counter value coming from the encoder versus just converting that into a range that we can use or that the VLC player, media player can use. And then the rest of this is just basic decision making depending on certain states and what we want to occur when that happens. So now we'll go back and we'll look at a couple of files, file formats, so that you know how to create your internet radio station list and how to set up your flash drive for your media player. Or, I'm sorry, the MP3 player. Now let's take a look at the internet radio stations and how that file works to help you with this. So we're going to go into our radio folder, and this stands for I, not L, I, radiostations.txt. So we'll open that in a text editor. And these are your internet radio stations. Now, getting these, there's a number of different ways you're going to get them. And I would start by doing a search on Google on different ways you can do it. I've got a technique listed here, and unfortunately I can't find the original website where I got this technique from. If I find it along the way, I will add it into either the comments here in the program or in the description below. But unfortunately, I just could not find the original source of this. But here's one technique for extracting them from the website here and this particular radio station. And I was able to incorporate that into here. So this is a technique to do it, and it's a little bit convoluted, but it seemed to work fine. However, the important part is this. There's 2 sections to each line here. Here is the description that shows up on your radio dial. It can be as long as you want or as short as you want. It will end with a comma, very critical. Then you should have a space, and then the URL. Now, here sometimes when you copy and paste this from wherever you get the URL from, you get that extra line feed in there, and we're trying to strip that out automatically in our software. But try to make sure that these URLs are as clean and proper as you can possibly make them. You may have to do some testing before it actually works out. But I will be providing this file with these internet radio stations in the software package. But you're free to add more to it or remove from it. Edit it in a plain text file editor, and you should be good to go. But again, very important. Your description first ends with a single comma, then a space, and then your URL to that radio station. And it's got to be to their stream. So keep that in mind. You can't just link to a website and it's magically going to figure it out. So that is your internet radio station's text file, and that is located in your radio folder that you're going to copy and paste onto your desktop. There's the graphics folder. That's going to have 2 images in it. I believe it's this one and this one, or maybe it's this one and this one. Either way, you're going to have 2 of those in there containing those logos that I put in the software, and I will hopefully have links either here or in the description on where I got those from via Google search and then to some original source. And of course you can substitute those files with what you want to. Just have to watch the width and height. You'll have to scale your image to fit into the space that's allotted. And then finally, the MP3 Directory Structure. Now first I'll show it to you very simply here, and then I'll show you what I use on my radio. You're going to have everything on a USB flash drive, and there's a port on the back of the radio where you can conveniently plug that in. That flash drive has to be called media in capital letters, just like that. Then on that flash drive, you're going to create a folder called Tunes. And in that folder Tunes, you will have a directory for each artist. For example, Jimi Hendrix, Pink Floyd, Mark Knopfler, the Beatles, the Beach Boys, etc. Then, in that directory, you'll have a directory for each album. Then, under each album is where you would have the songs for that particular directory. It's really quite simple. It's a very basic tree structure, starting out at the top end on a device, USB device called Media, that has a folder called Tunes, and in Tunes are a list of folders of your artists, and each album by that artist, and then every song in that album. So here's how the directory structure would look. In a very simple example, here's the USB drive, Media, folder Tunes. Under Tunes, the very first artist is Pink Floyd, and I've got 2 albums, one called Animals, the other album called Dark Side of the Moon. All the songs that are for Animals or on that album are listed underneath it, and all the songs that are on Dark Side of the Moon are listed under it. I've got another artist called Rag and Bone Man, and I just have one song from him, so I created an album name, a fake one called Human Single, and in there I loaded the actual MP3 file. And then finally another example of Dawes, the artist group Dawes, and then from their album We're All Gonna Die, and then one song, number 7, When the Tequila Runs Out. Now let's take a look at my actual USB flash drive. Now this is off the flash drive that I've got playing in my radio. Here's the name of the flash drive, media, and then under that is a folder called Tunes, and then in Tunes are all the artists. From Asia to Yes. I also got a couple of songs loaded in the very root directory of Tunes, and of course those will load too. But under, well, let's go to Pink Floyd. I've got these albums, and for each of these albums, I've got all of these songs, and they're all MP3s. I also got some other information in here, like album art, and the lyrics and so forth. They're in here as well. That's fine. Those won't get played, or they will not mess up the system. The only thing my software, or our software, does is it looks for the MP3 files and loads those into the lists that you select when you're playing them. Now let's go to Rag and Bone Man. That's down here. Again, made up the fake human single album, and here it is in an M4A format, an MP3 format, album art, and that's it. So the format structure is really quite simple, and it's fairly well organized so that you can keep all your music somewhat sorted and stored and organized both here or anywhere that you would use them. But they have to be MP3 files. I don't believe it'll work with any of the other types of audio formats. So that's how you would create your MP3 directory structure. Very, very simple. So that should wrap up this particular section on the software. I know it was a very lengthy discussion. I'm hoping you found it beneficial and not confusing. Some of the stuff gets a little bit hard to explain. Well, this wraps up the software overview and configuration of the radio project. I hope it wasn't too fast or too slow or too complicated for you, whatever the case may be. Provide some feedback down in the comments to help steer me along the way on what you'd like to see in future projects. So with that, let's wrap this part of the project up, and I look forward to seeing you in the next video.